Hello friends, I am J Doshi, working as Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. At the end of video, the students will be able to perform different operations on lathe machine. So different operations on lathe machine are: one, turning, eccentric turning, taper turning. So these three are the parts of the turning or types of the turning. Then facing is one more type, chamfering, then grooving, parting, knurling, drilling, boring and thread cutting. So turning is the operation which is carried out by removing the uniform material from the surface of the circumferential surface of the workpiece, which will reduce the diameter. For that, the tool travel is required to be parallel to the axis of the lathe. In case of eccentric turning, we have to remove the material such that the axis of the priorly turned diameter must be eccentric to the diameter which is to be turned now. Okay, like crankshaft, you might have seen crankshafts have the crank pin and the main bearing part or main bearing shaft where bearing is fitted are eccentric to each other. Okay, so eccentric turning is of course a turning, but the axis of different diameters on the same object will be different, will be parallel to each other, will not be same. Okay, in taper turning, it is a generation of a taper surface or conical surface. It also removes the material from the diameter, but it will be go on either ascending or descending the depth of the cut initially. So it is a generation of a conical surface by removing the material on the cylindrical part or on the circumferential part. Facing, here the tool travel is perpendicular to the axis of the lathe, which will remove the material from the face of the object, which will reduce the length of the object. Chamfering, it is removing of the sharp edges. After facing and turning, the sharp edges on the circumference are generated. So particular type of chamfers or particular type of tools are used to give different length chamfers depending upon the requirement. Okay, grooving, it is preparation of a groove or a undercut on the circumferential part is called a grooving. Now parting is the dividing or cutting the piece on the lathe by using grooving process. So groove is of a particular depth and particular width. In case of parting, if we go on grooving it till the center of the axis line, then it will carry out cutting of those two pieces, that workpiece into two pieces, that is called parting. Knurling, preparation of a rough surface, uniformly rough surface but smooth surface is called knurling operation. So the knurling tools are available which are harder than the material to be machined. So if you observe during in market when we use certain say tap wrench or certain type of fixtures or certain type of holding devices, those are given those are carried out with knurling for gripping or holding the grip on the material on the handles of the those tools. Okay, drilling is the operation. In case of lathe, as I told you, you can carry out drilling only at the center or along the axis of the workpiece or along the axis of the lathe. So drilling can be carried out by using the tailstock. Boring, after drilling, if you want to enlarge the hole, then you can carry out boring. Boring is nothing but removing the internal surface of the drilled hole. So it is also a turning, but the turning inside the hole is called as a boring. And thread cutting, it is generation of threaded surface either inside the board surface or outside the turned surface is called threading. So it is just like a nut bolt arrangement, you can say. So that type of threading can be done. Now there are different types of threads: V thread, square thread, helical thread. So many types of threads are there. That is not actually included in this video. So that may be another video. So thread cutting is done with the help of a lathe machine. Now in this particular video we will study turning, eccentric turning, taper turning, facing and chamfering, which are the basic operations. So this is a turning. So turning is the process of removing materials from the cylindrical surface of the workpiece to reduce the diameter. So in this case, if you observe, here the tool travel is parallel to the axis of the lathe, is parallel to the axis of the lathe or axis of the workpiece, and it will be removing the material on the cylindrical surface or circumferential surface of the shaft uniformly. Okay. And if you have a depth of cut, that is this material which we are removing with the help of tool, turning tool, if it is a 1 mm, then diameter will be reduced by 2 mm. Okay. So this is called a turning. So turning, in turning, you must keep in mind that the tool travel will be always parallel to the axis of the lathe. So this is called as turning. So in operation, the tool motion is longitudinal, that is parallel to the axis of the lathe spindle. Now imagine if I want to remove the, if I want to carry out the removal of the material from the face, that is this area. Now tell me, for removing the material from this area, what type of process or what type of tool travel we will be achieving, or we will have to implement. Yes. Now the turning, I told you, diameter material from the circumferential part or cylindrical part we are removing, but here we are removing the material from the face. So there will be a tool travel always perpendicular to the axis, and it will be removing the material from the face to reduce the length, not the diameter. So in case of, and that operation is called as facing. So it is given again, sorry, it is eccentric turning now. So this is the taper turning. Then eccentric turning I already wrote. So prior to that we will study about the taper turning. In this we are removing the material along the cylindrical part, but that will be of different depth. Here we will be removing more material, here we will be removing less material. Once we have carried out turning, suppose of this diameter, then this removal, here if you observe, we are removing more material compared to this, and this angle of the taper with the axis will be calculated by the length, this higher diameter or major diameter and minor diameter. So from that you can calculate the angle theta. That type of angle or that angle will be given to the tool. That angle will be given to the tool, and the tool movement will be along that line, along that angle, so that it will generate the conical surface or the taper surface. So it is the process of uniformly reducing the diameter of the workpiece along its length. So along this required length or defined length, we have to remove the material such that after setting that particular angle, the diameter here and diameter here we will be getting must be according to the drawing. Okay. Now regarding eccentric turning, if you observe, here axis of this priorly turned part. So this is the priorly turned part of the shaft. This is the priorly turned or turning carried out part for which axis is like here. Now later on I want this axis to be set in this parallel to the priorly turned shaft, but at a certain distance. That calculations are needed. Accordingly we will shift the job, or we will make it offline, off center, sorry, not offline, off center by the particular distance or given distance, and then again we will carry out turning operation. Again we will carry out turning operation. So now this part, if you observe this part of the shaft and this part of the shaft, they are not along the same line or same axis. So it is the process of removing the material from the cylindrical surface of the workpiece to reduce its diameter about an axis offset from the axis of the workpiece. So these axes of these two surfaces or two cylinders or two shafts, two parts of the shafts are not in the same line, those are offset. So this is called eccentric turning, which is usually required in case of crankshafts or some cranking action is to be needed. Now this is called facing. So here if you observe, this is a facing operation where we are removing the metal from the surface or from the face of the workpiece, which will reduce the length of the workpiece. So for that, tool travel must be perpendicular to the axis of the lathe. So it is the process of removing the material from the end surface or face of the workpiece. So that is called as facing operation. Now this is chamfering. So what chamfering? As I told you, when you carry out turning and facing, here there will be a sharp edge like this. So that may be dangerous to the person who is handling the material, one thing. Another thing, for inserting it into some cylinder, you need to have some angular cutting done here. So instead of going for taper turning, we will have the chamfer tool. So in prior process you might have seen there is a single point tool, cutting tool, whereas here it is a chamfer tool, which is set at a particular degree and it is made to touch to that corner or sharp edge, and it will go on removing certain material. In drawing, this dimension may be specified that the chamfer must be 2 by 2 by 40 degree, that is 2 mm along the axis, 2 mm perpendicular to the axis, and this angle must be 45 degree, 50 degree, 60 degree. So that will be specified on the drawing. Accordingly, we will after turning and after facing, we will carry out this operation called as chamfering. So it is the process of beveling the sharp end of the workpiece for avoiding the injuries during handling and for aesthetic look. Okay.